Hello, everybody. I would like to go through the solution of question 71 in calculus section of the course Maths 1151 at the University of New South Wales. Now, each of the following, we would like to find the limit when as x goes to the infinity, and then prove this by using the epsilon definition of the limit. Now, consider this function sine 3x over the x squared plus 4. If you have such an equation like sine divided by a polynomial, please consider this fact. Sine x for all x in real numbers is between -1 and +1, including -1 and +1. Now, this is true for all x, so it is also true for all 3x. Now, x squared plus 4 is a positive number, and then we can divide this inequality by x squared plus 4, and the direction of the inequalities will not change. So now we need to think about the pitching theorem. The limit of this will be 0. The limit of this will be 0. Since this function is between these two functions, and the limit of this is equal to the limit of this, then the limit of that one will be equal to that number, whatever it is. So the limit of this will be just as x goes to the infinity is 0. Limit x goes to the infinity of this side is 0. Then by pinching theorem, limit x goes to the infinity sine 3x over the x squared plus 4 is 0. So this is the first part of the requirement. In the second part, we would like to show that this is the limit by using the epsilon definition of the limit. So this is the definition of the epsilon definition of the limit. For every epsilon bigger than 0, for each epsilon bigger than 0, this bigger than 0 is not any real number. We are considering the closed epsilon, which is a number between 0 and 1. And our idea is to get closer and closer to the 0 because you want more precise to go for your result. Okay, epsilon between 0 and 1, we want to find out an expression depending on epsilon, such that for each epsilon bigger than the x bigger than the m epsilon, and satisfying to this inequality. This is fx minus the limit L. L is, in this case, will be 0. L will be 0. And this is our function. An absolute value. We want this one smaller 0. So we would like to find out that this m epsilon. So in order to be able to understand what kind of things that you would like to find out, or this is a clue part, let's have a look at this inequality and try to guess what we can do about m epsilon. So this is fx minus 0 smaller than epsilon. So this inequality is also smaller than 1 over x squared plus 2 because sine x is always smaller than 1. So this is what we figured out in this case above. Now, if we take epsilon here, smaller than epsilon, and then try to get x bigger than epsilon, yeah, and we are trying to this part, and try to find out this part. Okay, so this is smaller than epsilon. And then if we swapping this denominator and upper denominator and numerator will require to swap the direction of the inequality. So A is smaller than B if and only if 1 over A bigger than 1 over B. So we are going to use this fact. And we have this inequality. So take this 4 on the other side. And then you take the square root of it. As you see, we have an expression. X bigger than something. Square root of 1 minus 4 epsilon divided by epsilon. And we can call this one m epsilon, which is perfectly fine. Now we found an m epsilon, an expression depending on an epsilon, which bigger than x, such that this inequality is satisfied. Smaller than epsilon is satisfied. That is satisfied. That's all we want to. So choosing this also allows us, because we can choose this m epsilon as large as possible. So that is equivalent to get this inequality bigger and bigger and bigger. What I'm trying to say is that if we think in another inequality, for example, we know that this is smaller than 1 over x squared plus 4, but also this inequality is smaller than 1 over x squared. So we can consider that this is smaller than epsilon, and then look at the m epsilon expression, swapping the order, and then taking a square root. M epsilon will be 1 over square root of epsilon. This will be the perfectly fine choice as well. This we can choose, this we can choose, or we can choose anything bigger than this expression. This is the freedom that you can do for those questions. So either you take this one or you take this one. You need to write it down a conclusion in the end. Therefore, for all epsilon bigger than 0, there exist, this sign means there exist m epsilon. You either take 1 over root epsilon, or you can take root of 1 minus 4 epsilon over epsilon, such that x bigger than m epsilon and fx minus 0 absolute value is smaller than epsilon. So this inequality satisfied, this inequality satisfied, and m epsilon exist satisfying these equalities. That is true for each epsilon. And we're done with it. Okay, let's do another example, another question. Now, if the function is x plus 3 over x squared minus 3, by taking the x squared out, and this one will cancel out, when x goes to the infinity, this will approach to 0, this will approach to 0, this will approach to 0. So this will be 0 over 1, so it is just 0, so the limit is 0. Now we would like to prove this limit is equal to 0 by using the delta epsilon definition. For every epsilon bigger than 0, we would like to find m epsilon such that x bigger than m epsilon and the function minus the limit absolute value is smaller than epsilon. Now again, we would like to play with this one and find out an expression depending on epsilon such that all x's will be bigger than that and satisfy this condition at the same time. Okay, so x squared, x plus 3, x squared minus 3. So I choose to do this process because since x squared minus 9 is smaller than x squared minus 3, when we take the denominator to denominator, swap the denominator and numerator places, then we will have change the order of this direction. So this will be smaller this time, and this will 1 over x squared plus 9 will be bigger. Okay, because this one is a bigger number. When you divide it in the bigger number, this is a bigger number. When you divide 1 over the bigger number, you will get a smaller number. This is what I'm saying here. So I'm using this in here, absolute value, again the absolute value, but I can multiply this as x minus 3, x plus 3. I want to find out a simpler version of this rational function. That's what I'm trying to do. And then this one and this one will cancel out. I always only have 1 over x minus 3 absolute value. And this inequality means that minus epsilon 1 over x minus 3 is smaller than epsilon. With this inequality part, swapping the orders with the denominator and numerator trick, I have x minus 3 is bigger than 1 over epsilon. Take the 3 on the other side, then I have this expression, which is an epsilon depending an expression depending on an epsilon and x bigger than epsilon. So this is my m epsilon. 1 plus 3 epsilon divided by 3. I found my epsilon. It is done. I proved it. So, but we need to write it down nicely as a conclusion in the end. Hence, for all epsilon bigger than 0, there exists an m epsilon, which is 1 plus 3 epsilon over 3, such that x bigger than m epsilon and gx minus 0 is smaller than epsilon. Again, something else may work out as well. If you can find some other expression which can be in this side of inequality, then it will work perfectly fine. You can, but I think this is the simplest way to do it. As you can take m epsilon as large as possible, you can do this. Okay, next question. This is our function. If we have the limit, we can do it in two different ways. So this is x goes to the infinity. So this is infinite over infinite. We can apply L'Hopital's rule. That will be a 4. Derivative of the upstairs will just 4. Derivative of downstairs will be 1. And the limit will give you 4. Or you can choose another way to prove it. Take the x out. Then you have 4. And take the x out on the downstairs, you will have 1 plus x over 7 over x. When x goes to the infinity, this x goes will be cancelled out. This will be 0, and that will be 4, and that will be 1, and that will give us the 4. So the limit is 4. The question is, we would like to prove this with an epsilon limit definition by using a limit definition. For each epsilon bigger than 0, we would like to find an expression depending on an epsilon satisfying this inequality and this inequality. Start from this inequality and then trying to find out an expression for m epsilon. That's the idea. So for x divided by 7 plus x plus 7 minus the limit, which is the 4. And this multiply here, then we have 4x minus 28 over x plus 7. So this one and this one will cancel out. You have minus 28x plus 7. If you take this out from the absolute value, we have 28 over 7 plus 7 smaller than epsilon. And then swap over the order. Then you multiply 28 to here, and then take minus 7 on the other side. Then we find an expression depending on an epsilon, which is this guy. We found our m epsilon expression, and that's done. As a conclusion, for all epsilon bigger than 0, there exists an m epsilon, which is whatever you found in this way, such that x bigger than m epsilon and is satisfied, and also function minus the limit, absolute value smaller than epsilon, is satisfied. That's all. This is another question related to, this is the part D of this question. This time, but the function is exponential minus 2x. So the limit x goes to the infinity of this function is 0, as we know, because exponential minus infinity is 0. If you go to, because this is an exponential function graph, a to the 0 is 1, and when x is equal to, and this is equal to 1, that's there. So this is the exponential map. And the exponential map, and it goes to minus infinity, approaches to 0. It is just visual. You don't need this part. You just need to know this, and you need to be able to say that this limit is equal to 0. So we would like to prove this by using the limit definition for each epsilon bigger than 0. We would like to find out an expression m epsilon satisfying this condition and this condition. So this is the qx, the function exponential 2x, and the limit is 0, and the absolute value is smaller than 0. So we can take the ln function on both sides because we know that the exponential function and ln functions are inverse functions each other, which means that if we apply one to another, we will get exactly whatever we started with. In that way, we have minus 2x in this side, and we have ln epsilon in this side. If you multiply this by minus 1 over 2, this will become bigger than, because the negative, multiplying with a negative number replaces the order of the inequality. Then we have x is bigger than minus 1 over 2 epsilon. So 1 over 2 makes that it is a square root. So this minus 1 makes it inverse. So this is 1 over root over epsilon. So when you take this one as this is an order, this number goes as an order of epsilon, and that gives us this number. So this expression becomes an m epsilon in this time. We found an m epsilon, x bigger than m epsilon as an expression, and this condition is satisfied. Only thing that we need to say is a conclusion, therefore, for each epsilon, there exists an m epsilon ln 1 over root epsilon, such that x bigger than m epsilon and x e to the minus 2x is smaller than epsilon. So L is equal to 0. So this is satisfied, and m epsilon exists. Such an m epsilon exists. That's all for this question. Thank you very much for listening, and hopefully it is useful for you.